to start a new course. The course name is Design and Analysis of Algorithm. Design and Analysis of Algorithm. Okay. So this is the course name. Now, design. Let's see what are the things we will study in this subject. Okay, so this is the course outcome. So this is the course outcome. Clear? So what do you mean by course outcome? Course outcome means on completion of the course, student will be able to achieve all these outcomes. Clear? So here 8 outcomes are defined. These 8 outcomes is defined in your syllabus, knockout syllabus. Clear? So you can, I will send you the PDF. You can study, you can read the course outcome also. So outcome means after studying this subject, what student will achieve as an outcome for it. So that is for the course outcome. So the first course outcome is so you can I am not reading these outcomes. I will send you the PDF. You can read. But what we will learn through this course, that I will discuss in other way, in shorter way, not in this one. Okay. So this is the syllabus. Listed syllabus.
আমরা মুখটা দেখতে পাচ্ছি না তো।
This facility is not available in Google Meet. When the presentation will be okay. So this is the syllabus. So I took this syllabus from the university website. You can go through this syllabus, and there are 5 units. There are 5 units in this syllabus. Total, it required near about 36 classes to cover the whole syllabus. Clear? So now this is the important.
কয়টা ক্লাস আপনি বললেন? 6টা।
In your syllabus, university syllabus, it will have 36 classes. Now this is my lesson plan. Clear? So this is more important. So these are the class numbers. These are the lecture numbers or class numbers, and these are the topics that will try to cover up all these classes. Clear? So for every classes I mentioned what topic I plan to cover. So if everything goes well, then I think we can follow this lesson plan. Clear? But here, after every 6th class, I will take a test. Test means MCQ test. MCQ test in Google form. Clear? So these are the topics discussed in the next 6 classes. So after next 6 classes, we will take another test. This will be test 2. ওকে হ্যাঁ বেশ
বলছি একটা কথা ছিল বলছি যে স্যার এই বায়োলজি আমাদের মন্দিরা ম্যাম নেবে তো মন্দিরা ম্যাম বলছিল যে বায়োলজি ওটাকে একটু চেঞ্জ করে দিলে ভালো হয়
ওকে উই উইল ডিসকাস দিস টপিক এট দ্য এন্ড অফ দিস ক্লাস ওকে
ঠিক আছে
সো দিস আর দ্য লেসন প্ল্যানস in every class what we plan to learn, that things we mentioned here. So you will get a test after every 6 classes. Clear? So this way I will take 6 tests. Okay, and at last we will take a quiz, and as well as the assignment will be given. Also assignment will be given. So we will go through the 5 tests, 1 quiz, and one or two assignments. Clear? So this is the evaluation procedure I plan to execute in this particular course. So these are the textbooks or reference books. You can consult all these books, but the first book, that is a Coreman is a very good book for design analysis of algorithm. Clear? But this book is not so easy. It's quite bit difficult book, but it's a very standard book. And these are the all other book you can also consult. Clear? There are so many books and so many books also available in college library also. You can borrow those books for study. Clear? But Coreman is the number one standard book of this particular subject. Okay. Now, in our first lecture, in our introductory lecture, we'll understand the different features of algorithm. So, at first, we'll understand what we mean by the algorithm. So, this is the fourth semester. I think all of you already familiar with the algorithm. So, all of you already familiar with this term algorithm. At first, you heard this term in times of studying your introduction to C programming in second semester. I think on that subject also you heard this term algorithm. So what is algorithm? Algorithm is the step-by-step logic to solve a problem. If we solve the problem through some computer programming, then the step-by-step logical approach of the solution of the problem is called the algorithm. So, and the next time you heard this term in the subject of data structure. So, in the previous semester, when you studied the subject data structure, so here you designed so many algorithms of the data structures. Clear? So now, one thing I want to mention here, that is, algorithm is not the program. Algorithm is not the program. Clear? So then what is the difference between program and algorithm? Program means when we use any high-level programming language. If we use any high-level programming language like C, C++, Java, Python, so many high-level programming languages are available. If we write a solution using this high-level programming language, then it's become a program, and program is executable. There are the different system software by which we can execute a program, and through program you can give some input and you can get some output from the program. Clear? But algorithm cannot be executed. It's just a planning of the program. It's the planning of the program. So what will be you can say it's the blueprint of your program. So what will be the logic, step-by-step logic? Following those logic, we can solve a particular problem. That is the algorithm. So algorithm, there is no commercial software platform where we can execute the algorithm. So at first you have a problem. Then you design an algorithm and then write a program to implement that algorithm. Clear? This is the approach of solution of the program by computer system. So algorithm will be developed into program using some programming language. So then the question is how we write the algorithm. So I think all of you already know that you cannot write the algorithm using the direct syntax of any programming language. We cannot use the syntax of any programming language directly to write down the algorithm. So algorithm will be written by some pseudo operations or pseudo code. That is called the pseudo code. So that is not the proper code of any programming language. But pseudo code sometimes similar to some programming language, but it's not directly, the programming syntax is not taken in the writing of the algorithm. So in the coming classes we actually see all these things with clarity, how to write the algorithm. So we will see so many, we'll write so many algorithms, and how to write the algorithm we definitely learn that things. But in this point you just remember that algorithm is not the program, it's the logic of the program. Now this with this algorithm we have to understand some concept or features of the algorithm. So suppose you have a problem, you design an algorithm. Now until you are not writing the program, you cannot take the input, or you cannot get the output. So up to algorithm, if somebody asks you, how do you prove whether your algorithm is right or wrong? Got my point? Algorithm cannot be executed. Suppose you will be given a problem and you are asked to write an algorithm. You write an algorithm. Now if I ask you whether it is correct or wrong, so without writing the program, when we should prove the correctness of the algorithm. There are different mathematical tools, mathematical logic by which we can prove the correctness of the algorithm. So the first important thing we should remember about any algorithm, that is called the correctness proof. So you can prove the correctness of the algorithm, but it's not so simple. To understand the correctness or to prove the correctness of the algorithm, we should know the another subject very well, that is called the discrete mathematics. And here I definitely tell that discrete mathematics, that is the another course that is present in this particular semester. You have another course, discrete mathematics, in this fourth semester. Clear? Am I right? Discrete mathematics is in this semester. Hello, am I right?
Yes, sir. Yes, sir.
Okay. So I definitely mention one thing here. That means this is not a mere mathematical subject. You don't treat this subject as a non-departmental mathematics subject. This is very much departmental subject. And discrete mathematics is the backbone of the computer science, or you can say this is the language of computer science. If you want to explain any logic in computer science, you have to express through discrete mathematics concept. So learning discrete mathematics is very important. So actually people understand the importance of the discrete mathematics after studying the discrete mathematics. That's mean when they come in third year, fourth year, or in the higher studies, when they go in the higher studies, then they realize that discrete mathematics is a very powerful subject. But as this subject is in this particular semester, I think this is your opportunity to study this discrete mathematics seriously. So I will suggest all of you to take this subject seriously, discrete mathematics. Then I think your level will be, this subject definitely increase your level, clear, in the computer science domain. So when you write an algorithm, you need to prove the correctness of the algorithm. But when we write a program, then how we prove the correctness of the program? By testing. That's mean we give some input and we get some output, and we check whether the output is right or wrong. Then we can say that this program is right. That is called the testing. There are so many testing tools. For a larger software. So for larger software, correct proof of the correctness is the testing, by the testing method. So testing is a very important method to prove the correctness of any software. But for a small program, the correctness proof of the correctness is important rather than testing, because you never can give all sets of input for testing. So you cannot say for every input whether the program is correct or wrong. You cannot firmly you cannot assess that. But if you have the correctness proof of the algorithm, then you can say your program is right. Next is the efficiency. That's in performance of your algorithm. Efficiency. So writing the algorithm is not enough. Writing the program is not enough for all the time. Whatever you consider your introduction to C, or your subject data structure, or numerical methods, for all these subjects, writing the program or finding the output is the most important target for students. But by the subject design and analysis algorithm. So what is the name of the subject? The name of the subject is design and analysis of algorithm. So here in this part, if you look at the name of the subject, there are two important terms. One term is design, another term is analysis of algorithm. So here through this subject we actually learn the different designing technique of the algorithm, as well as we learn the different mathematical tools to analyze the algorithm, to test its performance, to judge the performance of the algorithm. So this performance may be in two types. One in terms of time and in terms of space. So performance of a program or algorithm can be considered in two different ways. In terms of time. So in terms of time means whether your program is fast or slow. Clear? So that is called the time complexity. That is called the time complexity. So when you judge the time parameter of the algorithm, that is called the time complexity. Time complexity. And the another performance called space. Space means we know that when your program will execute, that program will come in your primary memory, RAM. So obviously the program, in times of execution of the program will be present in primary memory or RAM. Now if your program occupy large space of the memory, if your program occupy large space of the memory, then definitely your system will be slow. So a program that takes large space of the memory will be considered as a low performance algorithm. So what should be your target? Your target should be retain your program such that it will take less amount of memory from the RAM. So that is called the space. Memory, space means memory. So when we test whether the space, what is the efficiency of the in terms of memory, that is called the space complexity. Space complexity. So I think these two particular terms, space complexity, time complexity and space complexity, I think you already familiar with or heard this term in your previous subject in data structure. So in data structure you definitely heard this term time complexity and space complexity. and sometime you already find out the time complexity of different algorithm or program, but that subject don't have the scope to to discuss the mathematical background of finding the time complexity of the program. So how we find out the time complexity of the program and space complexity of the program, that is a very important part of this subject. That is the very important part of the subject, and that's why this subject is, this analysis word is come in this subject. So actually finding this complexity, time complexity and space complexity, that's why this is called the analysis of the program. So you have to write down the design the program, as well as you have to analyze the program using different mathematical model. So these mathematical models are called asymptotic notation. Asymptotic, this term asymptotic notation, and one of the example of asymptotic notation is BIGO notation. So we know that the time complexity of bubble sort is BIGO n square. So in the data structure subject we just learned the time complexity of bubble sort is BIGO n square, but here we will study why it's BIGO n square and how it's how we calculate it as BIGO n square. Clear? So this is the one important aspect of learning this subject. Now this subject have other perspective also, important perspective also. Let's see what are those important perspective of this subject. The other important perspective of this subject is to modeling any problem. So you will have a problem, you have to model. This modeling means mathematical model. This is the mathematical model. Okay, so you have a problem, then you have to make a mathematical model of that problem. Then you design an algorithm. You have to design an algorithm. Clear? So at first you have a problem, then you convert that problem into some mathematical model, and then you write the algorithm, that's mean logic, and then you write the program. Clear? So this graphs is one type of mathematical model. This way you can use different type of mathematical model to represent your problem. Then you have to choose the proper data structure to implement this mathematical model. So whatever the mathematical model you will choose, so at first you have the problem. So let's see how we increase our conditions. So at first we have the program, then we find out the mathematical model, then we choose the proper data structure through which we can implement this mathematical model. For an example, suppose your mathematical model is graph. Suppose your mathematical model, you convert your problem into graph. Now graph cannot be understood by the program. Program cannot understand graph. Suppose this is the graph, so your program will not understand these things, because graph is an graphical representation. So your computer will not understand. Your computer will understand the data structure. So you have to convert this graph into suitable data structure. So what are the suitable data structure to convert the graph? That is called the adjacency matrix. Adjacency matrix. So we have the term adjacency matrix. So you have to find out the proper data structure, then you can write down the algorithm, logic, then you write down the program. Clear? So what is the flow of solving a problem? At first you have a problem, then you make the mathematical model of the problem, then you choose the data structure, then you put the logic, and then you write the algorithm into some programming language. Now it's become a software or program. Clear? But next, in this subject we'll study the different, I already told you that the first term of the subject is design. So there are the different designing technique of the algorithm. So here we will study the different designing techniques. So technique is what technique is? This is a design technique. This is the design technique of your problem algorithm. So there are so many designing technique. One designing technique name is divide and conquer method. Number 2 is called greedy method. Number 3 is called dynamic programming. So this way we will study the different program designing method. So here in this subject we study the different designing technique as well as we will study the analysis of the time and space of a program or algorithm. So this is the thing that we will learn after completion of this course. Clear? Next. So now what will be the background, that means prerequisite of learning this subject? The prerequisite of learning this subject will students should have know any of the programming language, high level programming, either you know C, C++ or Java, but you should know any one of the programming language to implement this algorithm. And another thing you have to learn, that means at first. So what is the flow of the you can understand that why the subjects are coming in this sequence in your program or in your course. At first you learn C. In second semester, then data structure, then algorithm. Okay. So to learn algorithm, knowing these two subjects is important. So you should know the programming language as well as you should know the data structure properly. Then you can understand the design analysis algorithm properly. So that's why basic data structure you should know. You should have the concept of basic data structure, array, list, graph, tree, all these things. Clear?
So list or link list?
List means linked list. Now today I will explain one problem and then we will see what is the scope of this subject. That means if you have a problem, your target is to write down the program of this problem, or your target is to find out the solution of the problem by software. So you have a problem, your target as a computer science engineer or a software engineer, what is your target? Your target is find out the solution by software, through software. Clear? So you definitely don't make the solution mechanically, you don't make the solution electrically, you definitely make the solution by software. So that means you have to automate the system. So now in the course of solution of this problem, what are the different steps of the problem that should be considered in the course of finding the solution of any problem. So when we have a problem, then how we should go forward to find out the actual solution of the problem, and step by step what we should follow, what we should consider to find out the proper solution of the problem. Just to understand this philosophical concept, this basic concept, I introduced here just an example. So through this example we will try to understand what are the different steps we will find in terms of finding the solution of the problem. Suppose your problem is air travel problem. That's mean in a particular country there are several cities, and suppose XYZ airline company have the different routes in between the different cities, and then you have to convert that problem through some software in the software domain. So let's see what is the problem. So at first you have to represent your problem. You have to describe your problem. Suppose we have a problem. At first you have to describe. Graphically you have to describe that problem. So in most of the cases we can describe the problem graphically, but anyway you have to describe the problem. So what is the problem? Suppose these are the cities: Delhi, Ahmedabad, Varanasi, Mumbai, Hyderabad, Kolkata, Visakhapatnam, Bangalore, Chennai, Trivandrum. So all these are the different cities. And suppose XYZ airline organization have the flights in between all these cities. Look at here, there is an arrow. There is an arrow in each and every line. Sometime in the line, arrow is in both sides. Suppose there arrow is the both sides. That means flight, there is a route from Delhi to Mumbai as well as from Mumbai to Delhi. But when there is a one directed arrow, so one-sided arrow, suppose this is the one-sided arrow, that means from Varanasi you can reach Ahmedabad, but from Ahmedabad to Varanasi there is no route. Clear? So this way you designed your problem, you describe your problem. Now in the second step you have to remove the extra information, the excess information from this problem. So now if we remove this map and the name of the cities and all these things, then this problem comes down into this type of representation. That means you just remove the map and remove the name of the cities, just keep the connection in between the cities, then your problem will be converted into this type of representation. Clear? So that means from your problem you convert it in some mathematical model. So this is that mathematical model. So this was your problem. But you convert this problem into some mathematical model. This is the mathematical model. Because this is a graph. This is nothing but a graph. So you convert your problem into graph. Clear? Now you can choose the proper data structure to convert this graph, and then you write down the algorithm. You write down the algorithm to solve this problem. Now when you will write down the algorithm, you may consider so many things. Now your graph may be converted into, may be changed, just keeping all these things intact. You can shift the position of these points, and just you can rearrange this graph without converting the direction of the vertices or the properties. Without changing the properties of the graph, you can just graphically change the thing. Clear? So actually whatever the graph is represented here, these things is same. This graph, these both graph are same. We just convert this. This is the overlapping line. We shift this overlapping line. So suppose this is the overlapping line. If you shift this overlapping line here, then this overlapping will be removed. So actually this is nothing but that, just removing the overlapping. So this way you can convert, you can simplify your representation. Clear? Now when you convert it into algorithm, then you may consider so many things. So what are the different consideration? So this consideration, on basis of this consideration, your software or your program will be rich. You may consider very simple thing, then your problem may not be solved all type of solution, cannot find all type of solution. But if you may consider different different dimension of the problem to implement within the algorithm, then definitely your software will be more powerful. So what are the different consideration? So consideration may be, suppose whether you have to wait overnight, or suppose there are so many cities, there are no direct connection. You have to go from that city to that city via other cities. Now, when you go through via other city, then obviously you have to wait. Now, how long you will wait? You may have some threshold of the wait. So if you remember all these things for finding the solution, then your version of the problem will be changed and your algorithm will be more complex or more rich. Another consideration is that you may consider the cost of the path. That means all the time you want to choose the cheapest route. Suppose for this particular problem you want to design a ticket booking software of this particular airline, then obviously when you write the ticket booking software for this particular airline, then you may consider all these parameters also. What are those parameters? That means whether that software will select the shortest route or shortest cost paths, all these things. Okay, and so through this example I actually want to show you that this particular subject is very important for a computer science engineer, or you can say for your computer science course. This is a very vital subject, because you should know that learning the computer science is nothing but learning the algorithm. So without learning the algorithm, you cannot be a computer scientist, because the main purpose of the computer science students is to solve the problem, and if you want to solve the problem, you have to write down the design the algorithm. And when you want to design the algorithm, you have to consider all this for consideration. That means whether your algorithm will be efficient or not, whether your algorithm can consider all type of possible parameters of the problem or not. So I think in this introductory class we discussed some fundamental thing of this subject, and we hope in the remaining lectures following our lesson plan we will cover all the topics that is present in this course one after another, and we will try to understand these things from the basic. And I think I always consider that students don't have any background knowledge, so always I try to make somebody understand from the basic. That's why I am requesting all of you to attend this class regularly, and it's my promise. I can say, if you can regularly attend this class, it's my responsibility to make this subject understand for you. Clear? So here I want to stop, and now I am asking you, if you have any query, you can ask me. Hello? Hello? Do you have any query? Hello, am I audible?
Yes, sir.
Yes, sir.
বোঝা গেছে? সব বুঝতে পেরেছো?
Yes, sir.
Any query? Any doubt? Or any other thing to discuss? কে একটা কি কোশ্চেন জিজ্ঞেস করছিলে? ক্লাসের শুরুটা কি কোশ্চেন জিজ্ঞেস করছিল? তোমরা সবাই কি শুনেছো? ক্লাসটা শুনেছো নাকি?
হ্যাঁ স্যার।
স্যার শুনেছি।
কি একটা কেমিস্ট্রি না কি একটা কি ক্লাস নিয়ে কি একটা প্রশ্ন করেছিল?
আচ্ছা স্যার, আমি একটা প্রশ্ন করতাম।
হ্যাঁ বলো
হ্যালো।
বলো বলো।
হ্যাঁ স্যার, বলছি স্যার, ডাইনামিক প্রোগ্রামিংটা কি খুব হার্ড?
না, হার্ড নট।
হার্ড নয়? মানে সবাই বলে নাকি ডাইনামিক প্রোগ্রামিং খুব হার্ড, ওই জন্য ডাউট হচ্ছিল।
কোনো কিছুই হার্ড নয়। আর হার্ড হোক আর তোমার সহজ হোক, তোমাকে বুঝতে হবে। হার্ড বলে কি তুমি বুঝবে না? তুমি যদি
সেটাই সেটাই।
ওটা কোনো ব্যাপার না। তোমার কাজই তো হলো হার্ডটাকে সলভ করে দাও।
একদম ঠিক।
কেউ লগ আউট করো, আমি অ্যাটেন্ডেন্সটা নিয়ে। তোমাদের একটা গুগল ক্লাসরুম বানিয়ে দেবো, ঠিক আছে? গুগল ক্লাসরুমের লিঙ্কটা বানিয়ে পাঠিয়ে দেবো। সবাই গুগল ক্লাসরুমে জয়েন করবে,
আচ্ছা স্যার।
ঠিক আছে? আর তাতে অ্যাটেন্ডেন্সের স্ক্রিনশট প্লাস যেই প্রেজেন্টেশনটা আমরা
স্যার কানে লাগছে স্যার।
যে প্রেজেন্টেশনটা আমরা ইয়ে করেছি, যে প্রেজেন্টেশনটা আমরা দেখলাম, এই প্রেজেন্টেশনটা পিডিএফ ফাইল আমি পাঠিয়ে দেবো। প্লাস যে ক্লাসটা হয়েছে এটা রেকর্ড করেছি, যদি রেকর্ডিং সব কিছু ঠিকঠাক থাকে তাহলে এটাও ইউটিউবে আপলোড করে লিঙ্ক দিয়ে দেবো, ঠিক আছে?
আচ্ছা স্যার।
যে এই পেজে প্রেজেন্টেশনটা, এই প্রেজেন্টেশনের পিডিএফ ফাইলটাও দিয়ে দেবো ক্লাসরুমে, গুগল ক্লাসরুমে, ঠিক আছে? পিডিএফ ফরম্যাটে। আর যদি রেকর্ডিংটা যদি ঠিক মতন হয়, রেকর্ডিংটা পাঠিয়ে দেবো, ঠিক আছে? ওকে, ফাইন। দেন if you don't have any query, then you may log out. আরো কোনো কোশ্চেন আছে?
হ্যাঁ স্যার।
ঠিক আছে, রাখছি তাহলে। বাই, ভালো থাকবে। নেক্সট রুটিন ফলো করে ক্লাস জয়েন করবে। প্রতিদিন এই একটা লিঙ্ক ইউজ করবে।